For learning objectives C and D, we're going to talk about how do you estimate correlation for the regression line, and where do you get it on the calculator, and what does it actually mean. So what it is correlation is always going to be a number between -1 and 1. And it indicates two things: the direction of the relation, and it talks about the strength or the magnitude. So if you know that the correlation or the R is positive, then it means it's a positive relation and that the data moves in the same direction. So if you were to look at a scatter plot, for example, and you had a line of best fit drawn, if the line is going upward means as X goes up, the Y goes up. So the data moves in the same direction. This will kick back a positive correlation. On the other side, if R is negative, it's said to have a negative relation. And when that happens, the data moves in the opposite direction. So what you're going to see in that case, again, if we have a scatter plot going down like this would have a negative relationship. So as the x's get bigger, what happens is the y's get smaller. Now if R is 1 or -1, it is said to have a perfect linear relationship. And if that's the case, then we say it has a perfect correlation. And there's two numbers that will indicate perfect correlation. Again, it's 1 or -1. If it's +1, it means the data moves upward. If it's -1, it means the data moves downward. What the 1 part indicates is that if you have a scatter plot, what's going to happen is that line will hit every single point on your scatter plot. Now, on a strong correlation, what you're going to find is that most data is close to the line. On a weak correlation, a linear trend, you might see it, but the points are not very close to the line. Now, when we look at the calculator and do a linear regression, what the linear regression kicks back is it says y equals ax plus b, and it tells us the a and it tells us the b. It's going to have two other variables. It's going to show us an r squared and an r. This r value that the calculator kicks back is the correlation. So just know that. This is what it's computing. You will not have to worry about this computation at all, but just know the calculator does take care of it. So I want us to take a look at these 6 graphs and kind of estimate the correlation. So if I were to draw a line of best fit on here, it looks like it'd be straight upward, hits every point. That's a +1. Below it, this guy, if I draw a line, looks like it goes straight down, it goes downward, it hits every point. That's a -1. If we go to B, this one is going upward, so it's positive. It's somewhat close, maybe, give or take, maybe it's positive 0.65 or 0.7 or somewhere in that range. This one here is going downward. It's a little bit more tight than the one right above it, so I'd give it a little bit higher number, but it is going to be negative. And I'm going to say let's do -0.8. Graph C, I'm not sure if I should draw this line or this line or this line or what. This correlation is going to be close to 0. And for letter F, if I was drawing a linear correlation, I don't know if I should draw it again this way through these points or this way through these points or how I should draw it. This does not have a good linear correlation whatsoever, and it's going to be very close to 0 also. So if you were asked to describe the correlation in context for the data, here's the thing you have to talk about. You must talk about the direction, and you must talk about the strength of it. So let's say that you were doing a problem and it kicked back this correlation. You would have to say it has a very strong negative correlation. Now looking at this graph, what do you think the calculator would kick back is the correlation? Well, we know we can cross off a positive 0.5 because it's going downward, so it can't be that. Correlations between -1 and 1, so it can't be this. It does seem pretty tight, but it is not perfect, so it's not this. Therefore, B is the most logical answer. Now there were a few more data sets that I did make some scatter plots for. So let's take a look here. On this particular data set, here's our scatter plot. For set 3, we have this one, and then for set 5. If you estimate the correlation, maybe that's a good line, maybe that's a good line. This one, I'm not really sure. Because I'm not sure on this one, I'd say the correlation is probably 0. This one here has to be something positive, maybe a 0.8. And this is a negative, and maybe again it's close to a 0.8 or so. This is a pretty important slide here in that what if someone told you that r squared is a 0.6 and they want to know what the possible values of r are? Well, if r squared equals 0.6 and you have to find r, the math behind it would say simple enough to get r by itself, take the square root. If you do that, you're going to get r is equal to 0.775. Now, this is not a complete answer because here's the thing. I don't know if r should be positive or negative. There's a direction to it. So to figure out if it should be positive or negative, all I know now is that there's two possible answers. If it's positive, then it would have to have a positive slope for the line. To be negative, the slope of the line would have to be negative. So you must look at the slope of your line to determine if this should be positive or negative. The last thing they want to highlight about correlation is causes, in that make sure number one here, correlation does not imply causation. And what that means is, for example, let's say I did a survey and I asked people, how many Snickers bars did you eat today? And then what did you get on your exam for a test score? If I graph that and the scatter plot was perfect correlation that it showed, the more Snicker bars you had, the higher the test score. You can't assume just because you get a really good correlation means that eating Snickers bars is going to cause you to have a high test score. You have to be very logical in the causation part. Okay. Number 2, the thing to keep in mind is that outliers. If you have outliers in the x or y coordinate, they can have a very strong impact on the slope, the y-intercept, and the correlation. Now, it doesn't mean you should remove them because they may be valid data points, but it's something just to be cautious of because they can really skew these 3 calculations.